All right, so 12.2, additional congruence theorem. So it's really more of the same kind of stuff, but we're also going to go into four-sided shape. So let's summarize what we saw. So there it is again, the three-letter combos that work and the three-letter combos that don't work. So pretty much any three-letter combo is okay, but not the AAA. These will not work, and not the bad word, forwards or backwards. You could do it backwards. It's just as bad. So any other three-letter combo works to prove that two triangles are identical. So then in addition, they're going to start giving us a bunch of theorems about quadrilaterals, four-sided shapes. It's really not new. It's just taking further the basic definitions. I'm not going to talk them all out in detail. I'm going to refer to them while we're in the homework. So there's some more. They talk about, the fact that rectangles really are parallelograms and all that. And I'll refer when we get to the homework. There's some more about kites and rhombuses and squares. It's similar to what we had before. This will be on YouTube if you want to read it over. It's also in your book. You can access the textbook anytime you're in a homework problem. If you're in the middle of a homework question, click on Question Help. Textbook will open up. You can go right to see all this as well. It'll also be on the YouTube, but I'm not going to read through it. Let's get right to the homework, and then I'll jump back when we need those definitions. All right, so question number 1 in 12.2. A triangle with angles 60, 70. They basically want us to draw, and we're not going to draw. We're going to do that next week. We're going to draw stuff. But right now they're saying draw, but we're not really going to draw with a protractor and a ruler, these figures. We're not really going to draw. We will do that next week. Right now we're just going to stop and say, hey, if we did draw, which of those would it look like? And just kind of get used to feeling it out. And then next week we'll get more hands-on. I will do some hands-on stuff, which is good. And we'll do some actual drawing of these things. But right now let's just think about, in theory, what would it look like? Which of those, A, B, C, or D, could in real life be a triangle with angles 60, 70, and an included side of 8? 60, 70, and an included side of 8. Well, right off the bat, do you see that we can eliminate C and D? Those are not it. Right? Why not? Well, because they have the 60 and the 70 and a side that's not between them. Right? They said included, so the side must be between the angles. And same thing here, 60, 70, and that other side is not between them. So C and D are not it. Let's just get rid of them right away. C and D, the side is not between the angles like it's supposed to be. But now, A and B, they both look pretty good. The difference between A and B is very subtle. They look all virtually identical, don't they? I got stuck here when I first did the homework and had to spend some time figuring out. So let me carefully explain the difference. So everybody good so far? A and B look real good right now, don't they? They both have the two angles. They just switched the 60 and the 70. But I mean, is that a big deal? You get the 70 here and the 60 here, and they put the 60 there and the 70 there. In both cases, the 8 is between them. Isn't that good? What's the deal? Well, it has to do with the angles affecting the side opposite them. But like we talked about, remember, a bigger angle will make the side opposite him bigger, right? So you keep that in mind. And now I honestly struggled with it first time, and then I reviewed the homework, and I got stuck again. So it made me really think carefully about it. So I think I have a way to make it really clear, because it was hard for me. So I spent time getting it really clear in my mind. Here's what helped me when I thought this way. I thought, okay, what if I had a triangle? Okay, and I had side A and side B. And I was going to put side C up there. What if I put C right in the middle? If I put side C there, right in the middle, point C, right above the very middle of A and B, well, then those two sides would be equal. Be an isosceles triangle, wouldn't it? If I put that dot right in the middle. What if now, instead of putting the dot in the middle, I let that dot go a little or a lot, let's just go way over towards the right. Now the two sides won't be equal. Which side will be longer, the left side or the right side? The left is way longer. The left is way longer than the right. This is the bigger side now. So when you move this point further to the right, it makes the left side have to reach further to get to that point, doesn't it? which means this angle must be bigger. This must be bigger because, remember, across from a bigger angle is a bigger side. Tracking with me? Right? That angle must be bigger because it's opening up across from it's a bigger side. So across from the bigger angle must be the bigger side, and you know the bigger side based on where that dot is, if it's closer to one side or the other instead of being in the middle. Well, that's what they're doing on this problem. Can you go back here and can you see this top right here and this top right here? Is it straight? And it's just pretty small. It's not a big difference. 60 and 70 are pretty close angles. Is it straight over the middle? No, it's actually moved a little bit to one side. That middle, is it closer to the right side or the left side? Right. Yeah, can you see it's barely a little closer to the right? Right? This dot is moved. You know, the center would be about right there. The center would be about right there. It's off center. It's a little bit to the right. So that makes which side have to reach further? This is the bigger side. In both cases, that's the bigger side, isn't it? Because that center dot is a little bit to the right of center. So the left side has to stretch further to reach the top. So that means the true real-life triangle will be the one that has this angle being bigger. So A is not it. It's B. This angle has to be the 70. Has to be the bigger angle, doesn't it? You see that? This angle is bigger because the side over there is bigger. Right? And this angle, this is the smaller side, just like in my triangle, this side was smaller, and this angle is smaller. So it's got to be B. In real life, it would look that way. Does that make sense? Hold on, 2 good minutes, and they're good minutes. Let me use them for your advantage. Let's go to part B real quick here.